Welcome to my presentation. In this presentation, let us try to solve quadratic equations by factoring. So let us take an example here. And in this example, we want to factor this example problem. 15a squared plus 18a is equal to 3a cubed. So in here, what we need to do is we want to bring it back to the quadratic equation form, and then to do that we're going to follow these following steps. Step number 1, we're going to write everything on one side of the equation, or one side of the equal to sign. So 3a cubed minus 15a squared minus 18a is equal to 0. I brought everything to one side of the equation, and then by looking at this expression now, there is between 3, 15 and 18, and then a cubed, a squared and a, 3a is common in all of these terms. So I'm going to pull out 3a as common, and what is left inside this brackets is a squared. 3a times a squared is 3a cubed minus 3 times 5 is 15, so 3a times negative 5a is negative 15a squared, and then minus 6 times 3 is 18, and therefore that is equal to, close brackets, and that is equal to 0. So 3a is common, so we pulled out 3a as common between all these terms, and what is left is a squared minus 5a minus 6, and we need to factor this part. And to do that, we're going to use the trial and error process. We'll use step number 2, and we will use the trial and error process. Let me write this a little bit more clear. Trial and error process. And how does that work? We want to try two numbers. The sum of those two numbers should equal the middle term, in this case, which is negative 5, and the product of the same two numbers should equal negative 6. So the two numbers we can, therefore, the two numbers we can think about are, how about negative 6 and positive 1? Okay, negative 6 and positive 1. Negative 6 plus 1 is negative 5. This is negative 5. And if we were to take negative 6, the same two numbers, the product of the same two numbers, and that should equal to negative 6 times 1 is negative 6, and that is what we have as the last term. So negative 6 and positive 1 are perfect. So these are the two numbers we are looking for. We will use these two numbers to expand the middle term, and therefore as step number 3, this is what we have. 3a is outside of the brackets, and a squared is inside the brackets. We have a squared minus 5a minus 6, and the middle term is negative 5a, and we're going to expand that by using these two terms. A squared minus 6a plus a is negative 5a, then minus 6 is equal to 0, and now we're going to factor them by grouping. So in here we're going to take look at the first two terms and then the second set of two terms, and then try to factor them out. So the way to do that is as follows. 3a, then in here a is common between a squared and 6a. If I pull out a, I'm left with a minus 6, and then plus 1 times a minus 6 is equal to 0. Now again, between this term and this term, we see that a minus 6 is common. If I pull out a minus 6, what is left inside the second set of parentheses is a plus 1. Therefore, that is going to be equal to 0. Now it is a matter of just simplifying these things. The way I can write this expression is 3a times a minus 6 times a plus 1 is equal to 0. By using the zero factor property, I can come back here and then say, call that as step number 4, either 3a is equal to 0 or a minus 6 is equal to 0 or a plus 1 is equal to 0. So let me write that here. 3a is equal to 0. Therefore, from here, a is equal to 0, isn't it? A 0 divided by 3, therefore a is equal to 0. The second one, a minus 6 is equal to 0. From here, if I were to add 6 on both sides of the equation, the negative 6 and positive 6 cancels out, therefore I'm left with a is equal to positive 6. And then the third expression here I have is a minus 1 equals to 0. Therefore, if I were to add positive 1 to both sides of the equation, so the positive 1 and negative 1 cancels out on the left hand side, leaving us with a is equal to 1. So a equals to 0, a equals to 6, and a equals to 1 are the three solutions for this polynomial which we started off with. Okay, so this is the way we want to be able to solve problems related to factoring quadratic equations. In my next presentation, we shall look at some more examples related to how to solve quadratic equations by factoring.